Uh, okay. And everyone can see this?
Yes.
Okay,
Yes.
perfect. Thank you. Thank you. Just wanted to double check. All right, thank you. Thank you so much for the lovely introduction. Thank you for the invitation. I'm really excited to be here. My name is Alvero, and I'm presenting from here in beautiful Ithaca, New York. And the name of my talk today is Generative AI in Sociology: the Good, the Bad, and the Beautiful. So before I get into the particulars of the talk, I wanted to begin with an example of the kinds of things I've been thinking about as it pertains to science fiction. So in 2016, a science fiction film by Denis Villeneuve called Arrival released. And in this movie, early on in the movie, these pods appear from the sky and land on different corners of planet Earth. No one knows where they came from. No one knows why they arrived. No one knows their purpose. So, in the film, this creates a lot of confusion and, tension among the characters. So later on in the film, some American scientists were trying to, they enter one of the pods and they're trying to interact with the aliens who are inside. Throughout the course of the film, they develop a means of communication with the aliens. And then finally, the movie hits its climax where the aliens they send a message to the humans which say offer weapon. So the problem is that in communicating with the aliens, the humans never learn to distinguish potential differences in meaning between the word weapon and the word tool. Just like in human language, a weapon can be a tool and a tool can be a weapon. And they were having trouble disambiguating what the aliens were trying to communicate, given fundamental differences between the ways that the aliens communicate and the ways that humans communicate. It's a fun film. I won't give away the ending, but this is a big kind of like point of contention. And for me, it reminded me of another moment where another kind of pod appeared out of nowhere, landed on planet Earth, and seemingly has changed everything. So in November 2022, ChatGPT was released to the public. And like the pods in Arrival, there's been a lot of discussion and confusion and intrigue and debate about what this all could mean, for now and moving forward. And also, like the film, there's been a lot of questions about what is ChatGPT going to offer us, particularly in academia. So there's a lot of think pieces out there. This is one I pulled off LinkedIn. Will ChatGPT destroy academia? Will ChatGPT destroy, this industry or that industry? These questions come up quite a bit. But at the same time, there are people who are a bit more hopeful, such as the recent example of an entire computer science conference where AI writes and evaluates every single paper. This was organized by James Zhu at Stanford University. And so far, the early response has been positive. I mean, I'm not saying I'm, necessarily endorsing it, but there has been this kind of like tension, this push and pull between, is ChatGPT and large language models and generative AI in general, do they offer weapon or do they offer tool? And it's this ambiguity that I use as a framework to analyze how generative AI is being incorporated into our field, in particular, sociology. So just to give you kind of like a roadmap of how this talk is going to look, I'm going to quickly go over results from a survey that I worked on with some colleagues. And the point of that survey was a very direct questioning of how sociologists are using generative AI in their research practices. So basically, I want to give a sense of how much of an issue is this for sociology? Are sociologists even uptaking generative AI into their toolkits, in general. After that, I'm going to, I kind of organize things, again, in the same way of like offer weapon has these kind of negative connotations, offer tool has these constructive positive connotations. To borrow, framing from another film, The Good, the Bad, and the Ugly, I'm going to talk about what could be potentially the good, these moments where generative AI is this positive, kind of productive tool for sociologists. Then I'm going to talk about what I feel is like the bad. And, instead of the ugly, from the original Clint Eastwood film, I'm going to present early preliminary findings from a study which actually literally looks at physical attractiveness or facial attractiveness in headshots generated by AI models. I also just want to give like kind of a disclaimer here at this point of the talk, where most of my research so far has been on what you might categorize as the bad side of things, where I personally have a lot of concerns. As was noted earlier, I was a high school English teacher, and I believe that there's a lot of power and potential in people writing, in terms of their growth and development, and seeing generative AI kind of be released into the masses the way that it has. I have some concerns and some worries. I'm not, I just want to be upfront, and I'm not trying to convince you that there's some line in the sand and you need to pick a side, but rather that, most of my work has been focused in that aspect, but not exclusively. So to begin, again, like this survey is answering this basic question of, are sociologists even using generative AI? And this paper is forthcoming in Sociological Science. Hopefully, there will be a version to share here pretty soon. The data and code are also going to be publicly available if you wanted to take a look yourself. So just to give you a quick overview of how we did this survey. So we wanted to identify sociologists and their collaborators, excuse me, basically people who are contributing to the sociological literature, some of which are people who are not in classical sociology departments or programs. So we identified 50 sociology journals, and we extracted email addresses from these journals for every article published in the past 5 years. And this gave us a total of over 18,000 email addresses. From there, we whittled it down in two ways. One is we wanted to get a sample of sociologists and people contributing to the sociological literature who use computational methods in their research. And our thinking there is that if generative AI is going to have a large impact on our field, it might begin with the people who are already using computational tools in their work. So, maybe there's like they're the vanguard of using generative AI in their research. And then we paired that with a random sample of everyone else. So, from this, we pared it down to a sample of basically 1,000 computational scholars and 2.2 thousand general authors. After some basic filtering based on who has email addresses available or not, and who's going to respond to our survey, we were left with 219 responses from people who use computational tools in their research, and this general pool of 214 other contributors to the sociological literature in the past 5 years. We do some weighting. I'm not going to get into that here, but there's lots of details that are in the paper if you're curious. So this was our sample. We had about close to 450 responses. And, with this kind of hitch where we're looking at people who are contributing to computational sociology. So just to give you some, again, these are just like broad strokes, some of the basic findings from this work. One of the questions we asked is just point blank, how often do you use generative AI in your research practices? So I know there's a lot of bars here. The yellow bars represent people who use computational methods. The purple represents this more general sample. And what I really want to bring your attention to is that about 1/3 of respondents report using generative AI at least weekly. And this isn't, I mean, yes, like the computational scholars are using it more daily, as you can see on the top row of this figure. But in general, 1/3 of sociology is using generative AI in their research practices. And I think the other important thing to note there is that this is actually in line with other studies from other fields about how often they're using generative AI in their research practices. So as one paper we found was a survey of biomedical researchers. So people who are like at least theoretically are fairly technical or have like technically involved research, and they're also using it at these same rates, which is to say sociology is kind of in line with other fields and other disciplines in terms of its usage. So then we also, one of the other questions we asked is, well, how often do you use it in particular stages of research? And the thing to note here is that most of the time right now, when sociologists are using it, it's in the planning and writing stage. In this question and in other questions, it also turns out that computational scholars are using it more often for coding, which is not too surprising. But in general, like, this is a thing, right? I guess is what I'm trying to get across. Like, sociologists are definitely using these tools, and they're using them in line with everyone else. So another set of questions we asked was concern. Something, and again, using the framing from the movie Arrival, once they realized they could interpret what the aliens were saying as offer weapon, you can imagine there was a lot of concern about what that could mean and what that implied. So here, we're kind of borrowing the same discourse that surrounds generative AI, and we ask, like, how concerned are you about these issues? And as you can see, just across the board, spread of misinformation, the power and control exerted by large tech companies, privacy, data collection, biases, etc. Everyone basically reported having a pretty high level of concern. We also asked questions about the costs. So, it's not just the case that, there are these kind of general concerns, but there's also trade-offs. So for example, bias you might think of in terms of, social costs, not to mention the studies about the environmental costs of generative AI and the data centers that they require. Those were in line with the other concerns. What people were less concerned about were the economic costs and the computational costs. And this is something I'm going to come back to in a little bit. And finally, another question we asked in the survey is whether or not people believe that generative AI is going to improve. And here we broke it up by people who were more familiar with generative AI and people who are less familiar with generative AI. And generally this trend, and we also solicited open-ended responses, and we saw kind of like qualitative versions of this. But generally there was some hope that generative AI, despite the concerns, despite the issues, despite the discourse, generative AI is going to improve. And maybe that could influence even more uptake in the future. So just to quickly recap here, so 1/3 of sociology, at least from our sample, is using generative AI in their workflow. This is in line with other fields. Right now, it's used mostly for writing, planning, and coding, but that potentially could change, and I'm going to show you examples of why I think that is. And there's lots of concern, even though it's less concern for the economic and computational costs associated with using generative AI. But with this caveat that there is hope and faith and belief that these tools will improve. So what I'm really trying to convince you of, by starting this talk, by going over this survey, is that generative AI could have some pretty serious staying power in sociology. And therefore, it's worth investigating what the models can and cannot do. And I understand that, maybe not for people in this audience, but, for colleagues who are in, non-computational, let's just call it subfields, maybe they feel like this isn't their problem. But if 1/3 of us are using it, maybe it is in ways that we're not really thinking about quite yet. So with that said, the goal for the rest of the talk is to give you, I'm going to give you a lot of different examples from different projects and different papers, most of which will be my own, but also, giving reference to other papers from, people who are leading this conversation. And, just to give a sense of this current state of affairs of generative AI in sociology. So I'm going to begin with the good. Okay, so what are some ways that generative AI can be used to enhance sociological inquiry, or at least not take away, detract, degrade, the practice of doing sociology or sociological research? So there's kind of two big buckets that for this talk I'm going to be focusing on. One is this emerging literature on annotation, extraction, and other methodological considerations. So here is just literally using generative AI as a tool for these types of tasks that are typical of our research. And then the second is being more abstract and more broad is like, is it possible that generative AI can lead to new forms of inquiry? So I'm going to be framing this part of the discussion on silicon sampling, which is the use of AI models to basically simulate human responses. And I have I'm going to break that down a little bit more in a few slides. There are other ways that AI, generative AI could be, in the good kind of, category. But, for the sake of time, I'm going to focus just on these two. And maybe we can talk more about it in the Q&A. So for annotation and information extraction, so just to give you, this should be a reminder of how this kind of work typically goes. So you have, it could be you, it could be a graduate student, it could be an undergrad RA, or you can have an entire team of undergrad RAs, graduate students, your collaborators, et cetera. And your goal is to, you each get a document. And this could be, an interview transcript. It could be a legal document that you're trying to extract to, do some legal sociology. It could be a social media post. It could be any kind of digitized form of text. And the goal is to, with a lot of traditional qualitative coding, is to have everyone on the team go through either the entire document or a section of the document and apply some kind of code book. And then fingers crossed that everyone applies the same codes in the same way. So you get high inter-rater reliability. This should be very familiar to all of us. And as we know, this is a process that takes a lot of time. You have to train either yourself, or your RAs, you have to create the code book, you have to, do some practice runs. It's a lot of time. It's also a lot of money. Paying RAs, do you have enough in your account? Do you need to go out and get a grant, et cetera? And then, of course, in the process of having a group of people read the same thing, there can be lots of moments where there's reasonable disagreement. Well, in this case, I'm interpreting this word that's kind of ambiguous in this particular way. There's nothing wrong with that, but, someone else might interpret it a different way. And then it leads to these kinds of cascading effects of disagreement that make it hard to, unify people on a particular project. But with AI, you can have one bot, go through an entire document and annotate and extract information, or you can have an entire team of AI models. You could have something where you have your OpenAI model and your Anthropic model and your Mistral model, all doing the same thing, and even coordinating with each other. And as you can imagine, compared to have training humans and going through the human version of this whole process, this takes a much smaller amount of time. This takes a much smaller amount of money, and there's less disagreement, even though there can still be disagreement across models. So, this is the kind of basic approach that people have been laying out for using AI for, annotation and information extraction. And I'll also remind you all that, the world has become extremely saturated in text. And if anything, the introduction of generative AI is going to, increase that saturation. So, I think it kind of behooves us as sociologists, if our job is to understand social worlds and society and people, interacting with and using text that increasingly shapes the world is going to be more important than ever. So I think I'm just trying to make an argument here that, regardless of, how we feel about, our concerns about generative AI, I think it's at the very least, it's worth considering the potential that AI has to help us better understand the world and the increasing amount of text that populates it. So just to give you one example, of why this is worth looking into, from an analytical perspective, there was a recent special issue in Sociological Methods in Research that was all about generative AI. And one of the papers was very specifically about annotation and information extraction. So in this paper, what they find is that they use a data set of obituaries published in the New York Times. And they basically, instead of training a group of humans to extract basic information from the obituaries, they have an AI model do it. And they tried a few different kind of approaches. So one, which you see on the figure here, is that they had a model that instead of taking in like the raw text from the obituary, they took in the obituary as a JSON file. They tried this like chain of thought versus no chain of thought. So, like kind of like multiple iterations, multiple prompts, to kind of get the response. And then they also tried zero shot, which is you literally just give the AI model the text and the prompts at instructing it what to extract. Or they tried it with one shot, where they give it one training example to learn from. So here, this is using a smaller open access model, Llama 3 Instruct. The Llama models are all, they're made by Meta, they're all open access. And the confidence intervals are pretty large, but you can see that, on average, the accuracy is 85%. And that's just like, here's the obituary, here's the piece of information that I want, and that's it. And just right out of the box, 85% accurate. So, and what was also interesting is that these design decisions, like, well, do we give it text or do we give it JSON? Do we give it one shot, like one training example, or do we give it not? Do we have chain of thought or no chain of thought? The accuracy did vary, but not by much. It was all the accuracies were still above 80%. And that's using the smaller model. Once they use the larger model, the 70 billion parameter Llama model, the accuracy was above 90% every single time. So again, like using that as an example, like clearly these models are, they're well designed for these types of tasks. I mean, you also can think about the fact that these models are essentially corporate tools for business and profit generation. And when you think of it that way, it's like, of course, in the daily kind of goings of an organization or a business, there are lots of moments where you need to accurately extract information from some database, from some piece of text. And just like in those cases, we want it to work well. It also happens to work well for us in our cases as social scientists. So I have one more example, and this is actually one that's starting to introduce some of my research. So in one project that I'm working on, we are analyzing a corpus of parole hearing transcripts from the state of California. So in California, there's this quirk where state policy mandates that parole hearings must be transcribed. What that means is that, starting sometime in the early 2000s, every single parole hearing transcript has been typed out and transformed into a PDF. And, here's one example. So in this project, we're working with every single parole hearing transcript from California from 2007 to the present. And these documents are very long. So California parole transcripts average 100 pages in length. And I also wanted to note that because, a lot of the times when we do computational text analysis or even like, some information extraction, we tend to be working with shorter form documents, social media posts, obituaries in the New York Times, college admissions essays, et cetera. So, like 100 pages is obviously like a lot more than that. And, what we're trying to do in this study is we're trying to extract information from the parole hearing transcripts that is not available elsewhere publicly. So, for example, something that will get brought up in the hearings are the rehabilitation activities that were undertaken by the parole candidate while they were incarcerated. And our goal of this study is to see if there's something happening in the actual parole hearings that can explain racial bias in the parole process for the entire state of California. And just to give you a very simple example, so we have been trying to see how well these AI models can do this task. And we used there's a new open weight model from OpenAI called GPT-OSS. And even though these parole hearing transcripts are 100 pages in length, one of my collaborators literally just gave the model an entire PDF and said, hey, I need this piece of information. And in 1 minute, done. Accurate, like got the information. It was kind of like, it was pretty eye-opening, for us and for me. So it was also the case that we had some previous manually annotated parole hearing transcripts, and my same collaborator, he ran those documents through the model, and it was actually identifying instances where the human annotators were inaccurate. I mean, it was just like, again, it was very eye-opening. And if you can think about the stakes of racial bias in parole hearings, using AI, like clearly it can be very helpful. So, just to wrap up this like good section, I also want to talk about silicon sampling. So, here's another situation that we frequently encounter as social scientists. Let's say you want to do a survey, and you write up your survey, you code it up on Qualtrics, and then you start recruiting participants. And of course, you don't need one participant, you need a lot of participants. And the same kind of issues with information extraction apply here, where there's a lot of time that goes into it. But in this situation, money becomes the bigger barrier to entry. Running a survey, a high quality survey, is extremely expensive. And maybe it's possible that AI can help with that. So there's a lot of papers. Actually, all three of these the bottom two papers appeared in that special issue of Sociological Methods and Research that I mentioned. And the first paper is there's a preprint, and it's under review. But what these and many other papers, not just from sociology, what they're saying is that you can just prompt the AI to give simulated responses. And you can even include demographic information to have the models respond like members of specific groups. And I know this sounds like science fiction, but I want to also give you a sense of what this looks like. So, literally, instead of having, a group of humans take your survey, again, just like in the annotation example, you can have different models. You can, take the survey and respond to it. You can set different parameters. You can have a little bit more variation in the responses or a little bit less variation. And then you could also include basic demographic information. So like, for example, let's say, in your survey, you wanted a response from, a typical American, whatever that means, right? So you include that basic information in your prompt, what do you feel about X, Y, and Z as an American? Or pretend, take the perspective of an American in your response. Or you could tell it to respond like they lived in Sweden or Cuba or Swedish Americans or Cuban Americans or Swedes in Cuba, et cetera, et cetera. It's really easy to, kind of like to adjust the parameters, like not just of the models, but also of the prompts. How easy is it? Well, it's about 10 lines of code. Like, I mean, this is literally like, I have a couple papers where we generate a lot of data from AI models, and it's literally just different versions of this. This is just basic Python code, import OpenAI, connect to the API. Here's the question: how satisfied are you with your current job on a scale of 1, 5, and why? You specify which model, you tell the model, and this is on line 11, you are taking a survey. And here you can also include instructions like respond to this question as if you were a citizen of Cuba or the United States or a woman or someone from, like, it doesn't matter, someone who's older, someone who's at the beginning of their career. And then you just print the response. So in just about 10 lines of code. So again, like, it's not just that these models can maybe do it. It's also that the systems that these models, that we have to use to interact with these models are really, really, really easy to use. And that's kind of like, one of the overarching takeaways that I hope you get from this part of the presentation, which is like, if AI models are, when they're good, there's a really like high level ease of use. There's the potential to save a lot of time and money, and it could work better than current methods and approaches, like in the example I gave where the AI model was catching human errors in our coding. So again, even like there's lots of reasons why we should still be wary of using generative AI in our work, and I'm going to talk about them next. But I think we need to take these tools seriously, even if we're in opposition to them in other ways. So now getting to the bad. And like I said at the beginning of the talk, this is where most of my research so far has kind of been playing, which are the ways that generative AI can degrade sociological inquiry and practice. And, a lot of my work also has kind of like an eye towards, the kind of broader social impacts as well. So, I'm going to also present kind of two buckets of what this could look like. One is that there's, these new forms of bias where it still has the veneer of seeming human to human eyes. Think of all the instances where people talk about how the AI text is human-like, it's human quality. And, if we don't take a step back and think about, well, what does bias look like when it's so high quality, we could be introducing new kinds of issues into our analyses that we're not even fully aware of. The other issue, and this is one I think about a lot, is AI homogenization, and that manifests in culture and language and science and innovation and research. And in my work, I kind of see these things as actually like fairly intertwined, where the AI models, everyone is kind of mesmerized by the fact that it's so high quality and it's so human-like. But I think when we zoom out, and you can start to see these broader patterns where it actually is kind of like shrinking variation in really important ways. So just to dive right into it. So, in one paper, this is a paper that I was on that was also in that special issue about generative AI and sociology. A common kind of element to include in a survey are open-ended questions. Everything I was talking about previously, most of those studies which showed like high levels of efficacy for generative AI and silicon sampling and using it to simulate human responses, most of those papers just focus on the basic kind of like multiple choice questions, or like really just again like how like a Likert scale kind of thing, like how happy are you with your job, how satisfied are you with your life, whatever. But the tools to analyze text, including open-ended questions, they're pretty good at this point. And one study that I mentioned that talking about here, we wanted to see like, well, how does the silicon sampling work when you use it to generate open-ended responses. So here in this paper, we compared human responses from previously published social science survey experiments, and we compared those with AI-generated responses to the same questions. So the first thing I'm going to show you is this is a sentiment. So the three papers here, one by Graham, one by Gronendijk, and one by we call them JSD. I'm so sorry to JSD, but I'm forgetting what JSD stood for. Apologies to them. I think it's Jardina and Stevens Douglas, but don't quote me on that. These three papers, these were three survey experiments that were fielded by the TESS, the times something experiments in the social sciences. It's like really high quality survey data. And each of those surveys was asking, they're basically like political experiments. Like all three of these papers they're done by political scientists. And here what we can see is that the AI models represented by the three colors on the left for each of these groups of bars, on average, they have much higher positive sentiment than the humans responding to the same questions. Which, if you think about that, like if the AI, if you're asking like potentially sensitive and loaded political questions, maybe the fact that you're getting negative responses is itself a signal of something happening in society. But with AI, it's kind of squashing that signal and giving you more positive text. And you can see that even more clearly when you look at negative sentiment, especially the JSD paper, which was talking about race. So, there's this potential where humans, again, are using much more negative language on average that, the AI, for lots of different reasons, including the fact that, at the end of the day, it is also a corporate tool that, they're just not going to interact with. They're not going to simulate human responses for very reasonable, kind of organizational, corporate-driven reasons. So in the same paper, we also, again, just looking at the language, so the purple distribution there, that's mostly normal. Those are, again, the human responses to the questions. And here, what I'm trying to show you is that, we took the responses and we compared we vectorized them using a word embedding approach. Then we compared those to like a group of words representing moral disgust. So again, with the humans, you get this like range of responses. Unfortunately, as you can imagine, some people are going to have like very high levels of association between disgust and race. And other people are going to have much lower levels between disgust and race. Whereas the AI is just it's not equipped to simulate those types of responses. Hence, it has this very narrow distribution, and it's to the left of the pile compared to the humans. And, again, if you're an organization, if you're OpenAI or Anthropic or Mistral or Meta, and you're creating these models, not for our use or for funsies, but to generate a profit, having a model that can really capture the full nastiness of the human spirit is actually a very weak sales pitch. So what I'm trying to argue here is that, these issues of can the AI models, at least when it comes to text, can it really capture the breadth of human expression? One is this paper suggests no, but then two, maybe they're never going to be able to by design. So in another paper, we took a slightly different perspective, and we wanted to ask this question of if you were to take AI generated text and compare it to text written by humans, in this case, college admissions essays written by high school students, which students do the LLMs write most like? Using this example, you might think they're writing most like whoever is more politically uh, you know, open to issues related to race as opposed to maybe far right respondents. Here is just more of like a style and culture kind of perspective of like who are students writing most like. So here we had a data set of over 140,000 admissions essays submitted to a public university system and a private university. And then we generated 25,000 essays, I mean, using code not too dissimilar from what I showed you earlier, from GPT 3.5 and GPT 4. And those were the models, the kind of latest models at the time. And we tried to induce variation by setting the temperature at 1.2 rather than the default 0.7. So a couple things here. One is like, again, just like in the previous example, the humans have this kind of generally normal distribution. And then the AI distributions of these stylistic features, in this case, which are represented by the black dashed lines, they're much more narrow. When AI generates a piece of text, it's going to be very similar every single time across 25,000 runs. The other thing I want to note is that this feature we're looking at in particular, analytic. Analytic was one of the features that is most predictive of an applicant's standardized test scores and their household income. So this isn't some like, inconsequential piece of information. And a couple things here is one is that the human distributions represented by the blue and red lines, they are slightly different, but they do, they also mostly overlap, but there is some difference. But you can still see that the red distribution representing male applicants, that's to the right of the female applicants, which is, to put simply, that means that, if you had to answer this question with some, with some caveats, this figure is suggesting that AI writes more like male students, has more of a masculine writing style. So here we also asked the same question, but looking at socioeconomic status. So EC, these are socioeconomic features generated by Raj Chetty and his lab at Harvard. And we had the zip code level information for the applicants, and we connected that to the zip code level information of the socioeconomic kind of activity in each student's community. And as you can see, as you move from EC1, which is the lowest level of socioeconomic status, that's most to the left. Then as you move more to the right, you're basically moving up the socioeconomic ladder. And then, again, just like with, these are mostly normal distributions. There's a fair amount of overlap, but still clear distinction. And basically what this is showing is that, it's also the case that AI models write most like the applicants from the highest SES communities. So in ongoing work, we also wanted to make this comparison in a couple of other different ways. So in that previous study, we only generated essays using these models based on, like literally just giving the models the same exact writing prompt. And here we started to include demographic information. And we also started to include more different models rather than just the GPT models. So what this is showing you is like, basically taking, word and sentence level information about the prompts, so like literally like TF IDF vectors, and then you do PCA, and then you project the first two components. Same thing with, we use T5 sentence embeddings, same exact thing. You can clearly see that the humans, there's this degree of separation between the humans and the AI generated text. And, yes, it's the case, like, again, the previous study was looking more at like who was closest to those boundaries, between the AI and the humans. But here, like what we can clearly see is that there is a pretty stark boundary. And, so we thought like, well, maybe this is just a quirk of the GPT models. And no, it was like every single model, there was this clear distinction between the ways that humans are responding to this prompt and the ways that AI models are responding to this prompt. So I also want to note that this level of separation, this is just with the first two PCA components. We have a classifier that included, I think it was like 20 something PCA or principal components. And we were able to get a classification accuracy between human and non-human of like 0.99999. One of the co-authors on this paper is actually he's a computer science professor here at Cornell, and he like didn't believe it at first, and he kept telling us to run it and rerun it and rerun it and rerun it, and we kept getting the same result. So clearly, there's the difference here between humans and non-humans. So we also started to look at, is it the case that there's, by demographic alignment? So here, the green prompts, this is cosine similarity between the AI models, like if it included demographic information or not. The red dots represent the humans. So this is like within group. So what's the cosine similarity between male applicants and female applicants? And then the blue and orange dots represent the cosine similarities between the human and AI generated essays, some of which included demographic information in the orange dots. And as you can see across the board, the AI models were much more aligned with each other than they ever were with the humans. And this idea that like, oh, we can just prompt the LLMs to sound like particular people or to respond like different people, in our case, it did not work. So I wanted to include, this is kind of like a meta point, and this is in another paper that I've been working on, what I call the state of the art fallacy. So, as we move, from low to high in terms of flexibility, which is kind of the general trend in computer science, there can be this pressure that, we need to adapt whatever the computer scientists say is the state of the art for our own research. We need to use the LLMs to advance the field of sociology. And I just want to argue that we should not assume that whatever the computer scientists are saying is going to always be the best tool for each and every one of our questions. And I hope that these examples that I've been giving you are examples of why that is. Okay, just to start, I know we're getting close to time here, so I wanted to wrap up by talking about the beautiful. So this is ongoing work about AI generated headshots. So literally, generate an image of, a doctor, of a plumber, etc. And there's two kind of points that I want to get across here. So one is that there's this issue of beauty bias in AI generated images of people. And it's also the case that at least in the preliminary results, that including demographic information does not really change this beauty bias issue. And I'll show you what I mean by that. And then also like, I hope this is just kind of like a general kind of like, poke and prod to us as a field. Right now, what defines computational sociology is like very much text as data type work, a lot of which I also like, contribute to, and I'm not criticizing it. I think, again, the world is becoming more text saturated. We need to be more aware of, these different patterns that emerge in digitized text. But I think there's also a need, and maybe AI can be the way that we start to think about it, to push beyond this particular mode of information as a way to understand the world. And I hope this is, this example helps convince you in some small way. So for this paper, and again, this is preliminary, this is ongoing, but I can also tell you that the results I'm going to share with you have been holding like again and again and again and again. So I feel fairly confident that, well, I feel very confident that these results will hold, in whatever final version we produce. So basically, in these pictures of humans generated by AI image generators, so diffusion models like DALL-E, one was like, can AI generate images representing diverse variety of people? So I also, just to be transparent, this was the original question for this study. But then, we kept seeing this issue of beauty and, everyone looking like supermodels, that we kind of shifted focus onto this other topic. But the original study was, how do these AI generated images, can they capture human diversity? And then, second is AI beauty bias is itself biased by race and gender. And then finally, how does beauty bias compare with previous image generators. So specifically, we look at StyleGAN2. This is a generative adversarial network. You have two models that are trying to trick each other, basically. And there's a website called thispersondoesnotexist.com, where, here's a person who does not exist. This is just an image created by a generative model, but not a modern generative AI model, this like generative adversarial network. That's what I'm going to be showing you next. So for this this method, or there missed a parentheses there. For this presentation, I'm just going to focus on the results that from looking at images of doctors. And I'll explain why in a second. But here we used three models. One was DALL-E 3. The second was Dream Studio, and the third was the StyleGAN2, which was we extracted from thispersondoesnotexist.com. So StyleGAN2 does not use prompts like DALL-E and other diffusion models. But for the diffusion models, we included prompts. We had 19 macro prompts, that are at the highest levels of demographic categorization, like female Black doctor. We had meso prompts, country specific or region specific from Cuba. And then micro prompts where we included racialized last names or names that are highly associated with particular groups of people, Wynn and Sanchez and stuff like that. So we use pretty standard computer vision tools, so CV2 and FaceNet, to extract the faces from the images. And then the method we used here was measuring attractiveness. And I also wanted, as a disclaimer, what I'm not saying is that this is an objective measure of beauty, but rather a fairly representative metric of what we might think of as conventional attractiveness, the kind of beauty and attractiveness that saturates, media, television, movies, magazines, modeling, etc. So it's a popular idea of beauty. And we actually used a website. There was a paper in research on, oh man, I always forget the full thing, the Stratification Journal, research something, Stratification Society, something. They used the same attractiveness website. And then, in the background, I also, like as part of the full paper, we're looking into other methods to measure the attractiveness of the AI generated images. So can it represent a diverse variety of people? So here were some responses to, generate an image of a Black doctor. Okay, it seemed to respond there. But it was even the case that when we specified, using the meso prompts, generate an image of a doctor from Nigeria. This was the doctor on the left, or a doctor from Ethiopia. That's the doctor on the right. Like, I'm not saying that these, I'm not trying to reify, what these images are, projecting, but at the very least, the model was responding to the prompts. So here were, Hispanic doctors. This was the one on the left was a Cuban doctor. The one on the right was a Mexican doctor. So still kind of responding to these particular demographic prompts. Anytime we prompted it to generate an image of an Asian doctor, it was basically split between East Asian and South Asian, which is kind of interesting. And then for white doctors, it was just that. It was also the case, though, that when images of white doctors would pop up, it would be, if there was no prompting. So there is this still kind of white default kind of setting. Although that wasn't always the case. Like this was another image that was generated an image of a female doctor. It was also the case that the average cosine similarity between the faces within groups was higher than between groups. So every time we were prompting it, it was making different faces, basically. So then is beauty bias itself is a bias by race and gender? So, there were differences by, for the Dream Studio. Oh, sorry, I see the typo there too. Sorry about that. For Dream Studio, as you got more specific, the average attractiveness rating would go down. But for race, we did every kind of pairwise comparison, and there was only one statistically significant difference that popped up. It was the case though that there were sometimes for male Black physicians that they were kind of rated a little bit lower. And the reason why I didn't include them in the first one is that there were some issues here. One was that they tended, the images tended to be looking down and away from the camera more often. And the model, the face extraction model and the attractiveness model would struggle to like extract their faces basically. I also know it's hard to see, but the image on the right, so the doctor, the doctor on the left, if you look closely at his eyes, you can see that there's some kind of like smudge, like AI image smudging, you might call it, that I think was like also kind of like biasing the results in a particular way. I'm not saying this to excuse the differences in the model by Black versus non-Black, but rather to point out that to me, one, these all still look like supermodels with very high average levels of attractiveness, as agreed with by the that website we used. But then also these were Black doctors in this case were more likely to have these kind of like weird blemishes in their images. So here's another one. Here's a comparison just to show you that the kinds of blemishes that we would see for the Black doctors, or the fact that they weren't looking, typically did not appear in other ones. So just to wrap up this and kind of the talk overall, so I also how does it compare with previous image generators? So these two images, these were some of the highest generated or highest rated images of from the AI models. So according to the the attractiveness website, these were rated 10 out of 10. And on average, the DALL-E images were rated 8.5 out of 10. And on this particular website, the average rating for any person is a 6. So, again, these they all look fairly attractive, right? So for StyleGAN 2, these were the highest rated pictures from this person does not exist.com. And on average, the ratings were 6.8, which is much closer to the average for that particular tool that we were using. These were rated somewhere between like 7 and 8 also. So, just to wrap up this paper and then the talk in general. So yes, can these image generators generate images of a diverse set of people? Yes, but at the same time, they're all basically Barbie dolls in the sense that, yes, they all look different, but they all fit this kind of like, they look like, soap opera stars and glamour models and such. There was some variation, but, just to repeat, in general, they all represent conventional depictions of beauty. And I know for this presentation, I was just focusing on doctors and nurses, but when we've been trying this with other professions and careers, like cooling and freezing equipment operator, we would get the same kind of results where they still kind of look like supermodels. So this person was rated a 9.14. So StyleGAN 2, just as a reminder, there is no kind of like reinforcement learning with human feedback. So it's literally just these two models trying to outwit each other, where, and there's just pictures used as training data. Whereas with these image generators, there's lots of human intervention. So I do think that I don't think that, the AI creators are like maybe very super intentionally trying to do this, or maybe they are, I don't know. But we do see that there is, my argument here is that there is something in the human process of making generative models that could explain these patterns, this beauty bias. I mean, here's another way to think about it. Why would an AI company change their models? Like if the models just generate images of beautiful people, maybe that's a good thing from their perspective. What are the financial incentives to change? Why be you when you can be perfect according to the AI? If you have it edit a picture of you. And it's a very practical example. TikTok uses similar tools, these similar like attractiveness rating tools to suppress posts by ugly people, and which is their words. So I do think that these qualities of images, a lot of the computer vision work in sociology, they'll look at pictures of protests and demonstrations and try and extract like particular elements. But here, clearly there's something else that we could be looking at. And I think there's a lot of potential here as kind of like a future set of research. So just to quickly come back to Arrival, is generative AI a weapon? Is it a tool? Is it our friend? Should I go to therapy with ChatGPT? Again, I'm not trying to get you to like sit very squarely on one side or the other, but I think that there's a lot of interest and energy of adding these tools to our toolkit. And I think, what could be helpful for us as a field is to start articulating the why of these use cases. And that could help us prevent more of these bad examples that I've been getting, but also further developing the good while also being mindful of broader social consequences. Thank you.